Hello dear friends, welcome to Gate Academy Global. So before going to start today's session, I would like to take the concurrence from each and every one of you that the quality of my video and audio, is it perfect or not? If it is perfect, we'll move ahead. So I'm waiting for the replies from you guys. The quality of video as well as audio, is it perfect or not? Then we'll move forward. I'm waiting for the replies from you guys. Love you dear, Mir Wakar, love you dear. Perfect, no? Perfect. Okay. Now in yesterday's class, basically I gave 5 number of questions as a part of your homework. I found in question number 4 and question number 5, few of the students got stuck in few of the critical points. So what I am going to do, although the agenda behind today's session is to cover the mean value theorem and Taylor series expansion, but before going into the great detail of MVT and Taylor series expansion, let me take the 2 questions which was there as a part of your homework. So let me go there. Here the question was question number 4 as well as question number 5. So first we are going to discuss about the question number 4. What the problem states, what should be the value of lambda such that the function defined below is continuous at x is equals to of pi by 2. The function f of x is being defined as lambda cos of x divided by of pi by 2 minus of x when the x is not equals to pi by 2. That means it's a complete function which is defined everywhere over the x axis except x is equals to pi by 2. That means in future graphically if we'll try to understand this function would make a whole at x is equals to pi by 2. Whereas exclusively the magnitude of the function f of x is found to be 1 at x is equals to pi by 2. May I know how much answer you guys have got for the question number 4? How much the answer you have got for the question number 4? And I know many of the students could have cracked this problem or you could have solved this problem, but still the way I am going to explain this problem is going to unfold so many technical details probably you guys may not be aware of. Yes or not? So what I am going to do, I am just going to take this problem for the sake of analysis, and we wanted to know the value of lambda such that the function f of x is continuous at x is equals to pi by 2. Rather taking the complete problem, let me take only the function part. See, this part I am taking it to the working board. Yes. Is that part clear? Sir, will give way constant available. We'll see that here. Now it goes to the solution. Yeah, yesterday also I have said, again I'll say one thing again. See, while I'll be teaching and you guys are focusing over the comments and all, what will happen, you may not be able to understand the exact technical details which I am communicating. So do one thing, rather focusing over the comments, just focus over the technical content which I am dealing. Try to write each and everything, try to understand in the great manner. End of the day, within the span of the complete session, I would be giving a window of 5 minutes, maybe 2 or 3 number of times. There I would be exclusively saying that whatever the doubt you guys are having, you can ask from me, and in that moment of time you ask whatever the question you have. So just focus over the technical content now. Is that part clear? Now what is happening over there, we want to have a continuity at x is equals to pi by 2. May I know how the function f of x would be continuous at x is equals to pi by 2? That part we have already seen in yesterday's class. The test point is clearly known for this problem. The test point c is equals to pi by 2 for me. And as far as the function to be continuous at c is equals to pi by 2, its left hand limit, I straight away may call it f of c minus, which is f of pi by 2 minus, should be very same as f of pi by 2 plus, and should be very same as the worth of the function precisely at pi by 2 itself, pi by 2 itself. Is that part clear? Now as far as the problem is concerned, once you will read this problem, you will get to know, just they have asked the value of lambda such that the function has to be a continuous function. So by default the limit will exist for this problem. See, if they are talking about the continuity, that's their problem, that at least this function should possess the limit at x is equals to of pi by 2. Otherwise, if it is not possessing the limit, or I can say the approach towards the left hand side and approach from the right hand side is not same, it won't be continuous. So if you want, you can check the limit of this function, otherwise you can straight assume yes, limit does exist for the function f of x, lambda cos of x divided by of pi by 2 minus of x, pi by 2 minus of x. Is that part clear? So now what is happening over there? So may I know which function you will be using for the calculation of function at pi by 2 minus and function at pi by 2 plus? Obviously the function which are defined in this region. You can see very well this function is not defined at pi by 2 and except pi by 2. This function is defined everywhere over the x-axis, and similarly, and I can say one thing, obviously pi by 2 minus and pi by 2 plus, they are the point after the pi by 2 and before the pi by 2. What does that mean of it? That means exactly it's not pi by 2, and hence the value of f of pi by 2 minus and f of pi by 2 plus has to be asked from the first function itself. Is that part clear? So now what would be the formula? It would be limit h tends to 0, f of c minus h has to be equals to of limit h tends to 0, f of c plus h, and has to be very same as f of pi by 2, where the pi by 2 is clearly known to be 1. Is that part clear? So rather x, I need to feed the c minus h in the given function f of x. See, it was a function of x, and once the function of x becomes the function of c minus h, what happens? Instead the c minus h has to be fed everywhere. And now for the calculation of pi by 2 minus, pi by 2 plus, the responsible function is this function, and hence everywhere instead this x, c minus h has to be fed in. So here, if we talk about its left hand limit, which would be equals to of limit h tends to 0, this one, f of c minus h, lambda will remain lambda, it will become cos of lambda by 2 minus of h divided by of lambda by 2 minus of, again x has to be replaced with lambda by 2 minus of h. So what will happen? Cos of 90 minus of theta is sin theta. That means this factor will become sin h, and here pi by 2 and pi by 2 goes off, negative will become positive. End of the day, it's simply gonna be limit h tends to 0, lambda times of sin of h divided by of h. Again, it's a case of L'Hospital rule. You would be taking a differentiation at numerator, which will become cos of h, and denominator it would become 1, and thereafter you will feed h is equals to 0. You will get to know your left hand limit is nothing but lambda. Or the worth of this is nothing but lambda. And similarly, you would calculate the right hand limit. What would be the right hand limit? So here it's gonna be limit h tends to 0. And thereafter it's gonna be lambda cos, instead the c minus h, now c plus h has to be fed to the function. So here it becomes, agreed, divided by of, here what happens here, where pi by 2 minus of pi by 2 plus of h. So end of the day, which result you get it out of this? See, cos of 90 plus of theta, it's a minus of sin theta, so simply it would become minus of sin h. This pi by 2 will go, and here the component which will be left out would be simply minus of h. Again, you are getting the same outcome, which is limit h tends to 0 minus sin of h divided by of minus of h. The minus and minus goes off, and here also the result is lambda. Here also result is lambda. So you got to know, yes, the limit does exist, because from the left hand limit, or if the function has been approached from the left hand side, or the function has been approached from the right hand side, in both of the cases the magnitude was lambda, and the f of lambda by 2 is clearly given in your problem, which is 1. So as far as this problem is concerned, they were asking the value of lambda. The lambda became 1. Lambda became 1. Lambda became 1. Is that part clear? Lambda became 1. So just I want, sir, booklet please. Booklet is already there in Telegram. Sir, will give way content available. Sir, booklet please. Is that clear? So I would recommend to each and everyone, at least try to share this session to your colleagues, your batchmates or your juniors, such that they will also get benefited from us. Is that part clear? They will also get benefited from us. Now, this problem is clear. As far as the answer for this problem is concerned, is simply equals to 1. Is simply equals to 1. Similarly, you had to go ahead with the next problem. So probably one student have also raised a problem on the question number 5. They were having the problem on question number 5. Now we can take even the question number 5 also. So now it's turn to take the question number 5. It's turn to take the question number 5. So try to understand what the question number 5 states. Try to understand what the question number 5 states. What the problem is stating: if f of x is equals to of ax square plus 1 for x lesser than equals to of 1, and similarly x square plus ax plus b for x greater than 1, the functions are found to be differentiable at x is equals to of 1, what must be the appropriate values of a and b? So in sequence, first value is a and the second value is b. I need to calculate this. So what I am going to do, let me take it to the working mode. Just a minute, let me go down. Let me go down. So here what it becomes, I need to take this question, I need to take this question. Till this. See, I need to take this question. Is that part clear? Sir, is it given this function is continuous at given point? I have checked it out, no? I have checked it out. So need not to worry much about it. I have checked it out as the left hand limit was same as right hand limit, and both of the values was got to be lambda. So you need not to worry about that. You need not to worry about it. Now, if we talk about this, I need to get the value of a and b such that the function as a whole f of x is got to be differentiable at x is equals to of 1. At x is equals to of 1. So let me start with solution. Let me start with its solution. Let me start with this solution. If the function is differentiable at point x is equals to of 1, by default it will possess the continuity at point x is equals to of 1. What does it mean of it? We have already talked about it. If a function is found to be differentiable, by default it used to be continuous and limit will also exist. Is that part clear? So I need to have the understanding the function is differentiable at x is equals to of 1. Virtually the function will also be continuous at x is equals to of 1. Now the people may ask why you are unnecessarily taking the concept of continuity. See. How many unknowns are there? There we have got the two number of unknowns, a and b. So until and unless you do not fabricate two number of linear equations, you would not be able to get the value of a and b. That is why forcefully I have taken another concept in the consideration, that if the function is got to be differentiable at x is equals to 0, by default it has to be continuous at x is equals to 1. Now taking both of the concept in our mind, you would be able to get the value of a and b. Is that part clear? What was the basic logic behind this? So now what I am going to do over here, see, continuity. How will you check it's a continuity? The left hand limit, right hand limit, and the worth of the function at x is equals to of 1 has to be very same. So first talk about the continuity. Continuity at x is equals to of 1. At x is equals to of 1. So what you will do? You will first calculate left hand limit, right hand limit, and the worth of the function at x is equals to 1. At x is equals to 1. How will you calculate the left hand limit? The left hand limit would be calculated by the same formula which we have been using, limit h tends to 0, f of, may I know what is your test point? That usually in general I take C as a test point. Now the test point is simply 1. So simply it will become 1 minus h, and similarly here it would become 1 plus h, and here straight away you have to get the worth of the function at x is equals to 0. Keep in mind the limits are the different thing and the worth of the function at x is equals to of 1 is entirely different thing. May I know from where you will get the worth of the function at x is equals to 0? See, this function is defined at x is equals to of 0, whereas this function has started defined just after x is equals to 1. So definitely x is equals to 1 has to be fed in this, and here it becomes a into 1 square. A is equals to 1 square plus of 1. A into 1 square plus of 1. Is that part clear? And now, if we talk about this, when this function would be valid? Definitely while calculation of RHL it would be valid. May I know what would be the worth of it? So now this complete process goes to you guys. I would just understand you would be able to calculate the f of 1 plus h, and you guys would be able to calculate f of 1 minus h. Straight away I am going to write the answer out of this. So here at right hand side it became a plus 1. And now for f of 1 plus h, the value has to be fed from this. Once you will calculate its limit, you will get the answer as a plus b. And similarly here, once you will feed left hand limit, you will be getting answer as a plus 1. Comparing the starting two equality sign. So from here what happens? A and A goes off. From here you would get the value of b, which is equals to of 1. Is that part clear? So one conclusion you could derive from this outcome, and that is nothing but b is equals to of 1. Now it's a turn for the differentiability. The differentiability has got its formula. That's nothing but the limit h tends to 0 f of c plus h minus of f of c divided by f h has to be equals to of limit h tends to 0 of f of c minus of f of c minus h divided by f h. Otherwise you do one thing. The equation before x is equals to 1 is ax square plus 1, and similarly the function after x is equals to of 1 is x square plus ax plus b. So what we will be doing, if the function is differentiable at x is equals to of a, that means the differentiation of the function has to be very same at x is equals to of 1 minus, and at the same time at 1 plus. 1 plus. Is that part clear? So rather taking a complete theoretical understanding of theoretical process in which we used to have all of the formulas, straight away do one thing. May I know at 1 minus which formula is valid? Definitely this formula is valid. You just differentiate that function with respect to the x and feed x is equals to 1. So let me differentiate this. What would be the differentiation over this? It's gonna be 2ax. Is that part clear? And here I need to feed x is equals to 1 minus. Hey, do not feed minus 1. No, 1 minus means the value is very near to 1 towards the left hand side, or I can say it's equals to 0.99999 approximately equals to of 1. So at last I need to feed x is equals to 1 itself. Now what about here? You need to take the differentiation of the second function, which would become 2x plus of a. And here also the x has to be fed as 1. Is the part clear? So let me feed the data. Here it will become 2 of A. Here it will become 2 plus of A. So A will get shifted towards right hand side, and you would be getting the value of A. So you could get the value of B as well as value of A. You could get the value of B as well as value of A. Is that part clear to all of us? B is 0. May I know that? Why the B is 0? Okay. Is that part clear? Okay, yeah, B is 0. Sorry. B is 0. Yes, B is 0. While calculation, the result what you will be getting, that's nothing but B is equals to 0. B is equals to 0. Yes, you can cross check this. Just for the sake of understanding, I have taken this. But now a very important thing comes into the picture. See, very important thing comes into the picture. What is that? I would recommend to each and everyone at least have one 2D drawer on your mobile application. So in future, once you are very acquainted with the function and how physically functions look like, the many of the topics which includes limit, continuity, differentiability, area under the curve, maxima, minima, there are so many topics within the mathematics will by default get cleared. Is the part clear? So I would recommend at least have one 2D drawer, and I'll try to understand how physically we can understand the each and individual concept. So far mathematically I was dealing each and everything, but let me take this problem and let me deal this problem graphically. Is that part clear? So what I am going to do, just a minute. Let me connect my mobile for screen mirroring. Just a minute. I'll show you how you guys could really enjoy the mathematics. Just a minute. 913084. Just a minute. 3084. So I would recommend each and everyone should have at least one. So this is what the mirror of my mobile, and now I would suggest at least have this 2D drawer in your application, which is Desmos. You can see this is Desmos. Now what happens? Drawing the curve becomes much easy. Like if I wanted to draw the curve which I have just seen, may I know what was the curve? The curve was, you can go to the function cos of x divided by of pi by 2 minus of x, probably pi by 2 divided by of x, pi by 2 minus of x. Yes. So you can see how the cos of x divided by of pi by 2 minus of x looks like. Now the people will say, sir, where the lambda have gone? I have assumed the value of lambda is equals to 1. Now what I am going to do in next step, let's take the value of lambda as 2. So if I take the lambda as 2, the function becomes 2 times of, let's take the function is cos of x, which is getting divided by again pi by 2 minus of x. It's a pi divided by of 2 minus of x. Yes. So we have drawn this. Let me do one thing. Let me enlarge this case. something like this, something like this. So what I am going to do now, now let me copy this image, and bring it to the working board, bring it to the working board. Let me take this here, image, this, see, this is very important image. No, many of the things you are going to learn from this image, Now try to understand, this was the function, just a minute, where the function f of x is being taken as cos of x divided by of pi by 2 minus of x, and the blue curve was drawn taking the lambda is equals to of 1, and similarly this orange curve has been drawn taking the lambda is equals to of 2, Is that part clear? And where the continuity test has to be made, at x is equals to of pi by 2. Once you will calculate the approximated decimal value of pi by 2, you will get to know the approximated pi by 2 value is somewhere 1.5, This is 1, this is 2, this is 3. So 1.5 will come somewhere here. 1.5 will come somewhere here. 1.5 will come somewhere here. So what I am going to do, let me draw a vertical line through this. Sort of this. And as the function f of x cos of x divided by of pi by 2 minus of x was only defined not equals to of pi by 2, that means the function will make a hole over here. So in yesterday's class, many of the students had the doubt, sir, what does it mean by the hole? What does it mean by the dot? So now you guys must have the clear-cut idea. This function is not going to decide the magnitude at x is equals to of pi by 2. The worth is almost 1.5, and hence it will make a hole over there. And even you can see the function lambda cos pi by 2 minus of x is a continuous function, because at 1.5 or at pi by 2 there is no sudden change. May I know when the function lambda cos x divided by of pi by 2 minus of x will become a continuous function? It will become a continuous function only the worth of the function at pi by 2 is equals to of 0 will become exactly 1 if the value of lambda is 1, and it has already been clearly given. The magnitude of the function at x is equals to of pi by 2 is simply equals to of 1. That means exclusively you can put dot somewhere here. See, dot somewhere here. So may I know what must be the appropriate value of lambda such that the function would be a continuous function at x is equals to of pi by 2. Already you have got a dot over here. With respect to the change in lambda, you have got the different functions. If you are changing the value of lambda, you are getting a different function. May I know which function looks a very continuous function? Once the value of lambda is 2 or once the value of lambda is 1? Once the value of lambda is 2 or once the value of lambda is 1? Obviously here you can see the magnitude of the function when the lambda is equals to of 1 reaches to 1 at x is equals to of pi by 2, and even the worth of the function at x is equals to of pi by 2 is equals to of 1. That means the function as such is making a hole over there, but this is making a dot over that hole. That means the hole and dot got fixed and they are continuous. So if this concept is clear, just say clear. And as I have suggested, each and everyone should have at least one 2D drawer in your Android mobile. in your Android mobile. Is the part clear till this point? Is the part clear? So just that is what I wanted to say. So if the value or the magnitude at x is equals to pi by 2 is fixed to 1, there is no other way. The function should have the lambda is equals to of 1, then only it will cross through this dot, although it will make a hole over there, and if hole and dot got submerged to this point, you can say yes, the function is continuous at x is equals to of 1.5. 1.5. Is the part clear? So if you got this in clear manner, just write like. So I'll get to know, yes, the people are enjoying it and definitely they are learning so many things from this graph and all. Graph and all. Tell me remaining one. Remaining one. Okay. So we'll move forward hereafter. We'll move forward. So let me go into the next slide. Let me go into the next slide. Now from today onwards, as I have said, I will start mean value theorem. Mean value theorem. I will start mean value theorem. Is that part clear? Now, as far as the mean value theorem is concerned, the mean value theorem can be bifurcated in the three different segments. Can be bifurcated in the three different segments. Three different segments. The first segment is Rolle's mean value theorem. It's called Rolle's mean value theorem. Mean value theorem. In short, I would be referring it by RMVT, where the R stands for Rolle's and MVT stands for mean value theorem. So in many of the times, instead referring the complete name, even in GATE examination also they have referred the Rolle's mean value theorem by the name of RMVT. RMVT. The second kind is going to be Lagrange's. Lagrange's mean value theorem. Mean value theorem. Which I would be referring, as I was referring RMVT, I would be referring it by LMVT. LMVT. Similarly, the last is gonna be Cauchy's mean value theorem. Mean value theorem. Mean value theorem, and which I would be referring it by CMVT. 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 So now let's start focusing over the first kind of mean value theorem, and that is nothing but the Rolle's mean value theorem. And I would say one thing, as far as the GATE is concerned, the mean value theorem is not that important, but still I can say the domain from where the questions are rarely asked, expected is there, the problem may come from those domain. I can say very rarely the problem have been asked from this domain, so you can say the chances are more to pick the questions from this domain. Let me go to the next page and put it the heading as RMVT. Rolle's mean value theorem. Is that part clear? Now within the Rolle's mean value theorem, first we talk about the conditions within the Rolle's mean value theorem. Conditions. The first condition, f of x, the function through which you are going to explore RMVT, that function f of x has to be, you have to write each and everything, has to be continuous within the closed interval of a comma b, and has to be differentiable differentiable within the open interval of a comma b. Has to be differentiable over the open interval of a comma b. You can say whether it's a one condition. In books or in standard facts, they used to write as a two different conditions. The first condition, fx has to be a continuous within the closed interval of a comma b, and similarly they write the second condition, the function f of x has to be differentiable within the open interval of a comma b, within the open interval of a comma b. Is that part clear? So you can write the second condition, and that is nothing but the worth of the function at x is equals to a is precisely same as the worth of the function at x is equals to b, at x is equals to of b. So what the conclusion RMVT gives, if you are satisfying each and every conditions which have been given with the point number 1 as well as point number 2, so what's the conclusion is given by the RMVT. What's the conclusion is given by the RMVT? The conclusion is at least, just a minute, the conclusion is at least one C which will belongs to the open interval of a comma b will be there where the slope is equals to 0, where the slope is equals to of 0, the slope is equals to 0, where the slope is equals to 0. Is that part clear? Slope is equals to 0. Now graphically try to understand what it means of. Graphically try to understand what it means of. See what it's trying to say. First, the function has to be a continuous function within the closed interval of a comma b. The function has to be differentiable within the open interval of a comma b. Similarly, the function's worth have got to be very same at x is equals to a as well as b. And if this all three conditions are getting met, at least one c would be there within the open interval of a comma b such that the slope of the function at that point would be 0. At that point would be 0. Is that part clear? May I know what does it mean by the closed interval and the open interval? If you talk about a big bracket, so it is called as a closed interval, and in closed interval you used to account all of the numbers from a to b including a and b, and if we talk about the open interval, that means you are going to cover all of the datas or the points from a to b excluding a and b. That's the difference. That's the difference. That's a different thing together. Mathematically we write using a small box and big bracket. Is that part clear? Now we'll try to understand mathematically. I'll try to understand this thing mathematically, what it tries to say. It's a very, very important, and really you will like this concept. How the mathematically Rolle's mean value theorem stands for. What it says. You have got the 2 points x, two boundaries at x is equals to of a and at x is equals to b. Let's take here you have got x is equals to b. At x is equals to b. What has been clearly given? It has been clearly given the magnitude of the function. What is that? The magnitude of the function at x is equals to of a and x is equals to of b is very same. What does that mean of it? If the magnitude of the function is very same, what will happen? Both of them would cross from the same horizontal line. Yes or no? Would cross from the same horizontal line. So I have taken a function, just assume I have taken a function which has the same magnitude at x is equals to of a as well as x is equals to of b. Let's take this function is f of x. The yellow pen has been used for the f of x. And as I am saying, it has got the same magnitude at x is equals to a, x is equals to b. How did you know that? You just see the coordinate values at this point. The coordinate values are x is equals to of a, and the magnitude of its ordinate is f of a, just a minute, f of a, and here it's gonna be b f of b, and if the magnitude of the function is very same at x is equals to a as well as x is equals to b, they would have the same height, and if they have the same height, they would cross through the same magnitude. See. Even I would explain this concept in the great detail, you would also come to the same result as the Rolle's could come to a certain result. What the Rolle's have said, at x is equals to a and at x is equals to b, if the worth of the function is very same, obviously it's very same, then in between a comma b at least one c will lie in such a way that the slope of the function would be 0 at that point x is equals to of c. See here, if this function is increasing, but you have make one thing sure that at x is equals to of b, the worth of the function has to be very same as at x is equals to a. So if the function is going up, it has to come down, no? Then only it will cross through the same magnitude. So if the function is going up and it has to come down, so certainly there would be a certain point where the slope will become 0. What's the great over there? I don't understand why the people are so afraid with the Rolle's mean value theorem and why they buy hard something. Not only that. So let me do one thing. So somewhere here you have got x is equals to c. Somewhere here you have got x is equals to c. Yes or not? Obviously yes. Where the slope is 0. Now you can have another type of function. Let me take another color for that. Which color I should take? Let me take the pink color. The another function is a decreasing function. Try to understand. Decreasing function, but it has been already made sure the function worth at a and b has to be very same. So crossing through this point, again it has to go up. Let's take this function is g of x. Again the same concept will happen. If it was keep decreasing, but you have forced one thing that it has to come to the same magnitude of f of a is equals to f of b, it has to go once again upside, and once it was keep decreasing, at the moment where the slope got 0, it will be keep increasing. So again you would be getting at least one point c within the span of a comma b where the slope of the function would become 0. Yes, you may call it c1, you may call it c2. Agreed. Now I am taking a crazy curve. Like I have got a curve something like this. See, sort of this. Let's take this curve is h of x. What is happening over there? Again at x is equals to a, the magnitude of the function h of x, and similarly the magnitude of function at b h of x is very same. Now may I know how many times it has got the slope is equals to 0? The first point is this point, second point is this point, third point is this point. What's the conclusion? May I know what's the conclusion? The conclusion is very sure. Sir, if you are going up, you have to come down to match the magnitude. If you are going down, you have to come up to match the worth of the function. Definitely at least one point c will fall in between a comma b where the slope of the function would become 0. What's the great over there, my dear? What's the great over there? May I know one thing? Really now you have to by heart the Rolle's mean value theorem? No, not necessary. Not necessary. You need not to by heart the Rolle's mean value theorem from here onwards. From here onwards. Is that part clear? Now, the people are definitely going to ask. Now the people are definitely going to ask, sir, till this point each and everything is okay. Till this point each and everything is okay. If function's worth at x is equals to a is very same as x is equals to b, there would be at least one c in between a comma b such that the differentiation of the function at point c would be 0. Is that part clear? Now, one more thing. Why these additional conditions are also applied with these sentences? See, Rolle's was very smart. What he was trying to communicate, did you notice? Now, if you have made another function I of x, let me take another color. Which color I should take? Let me take a green color. It is crossing through again the same magnitude, and see, as far as the worth of the function is concerned, at extreme values at x is equals to a and x is equals to of b is very same. So as per the requirement or as per the statement, at least one should be there within the open interval of a comma b where the differentiation of the function must be 0. Now you can see here the slope was positive and here the slope was negative. So can I say the slope at this point is 0? Can I call this point as a x is equals to c? No. Why no? Because here the function is forming a curve, and wherever the curve formation takes place, the functions are said to be non-differentiable. That means the complete fundamental that at least one c would be there within the open interval of a comma b got defeated. and that is why my Rolle's bhai was so smart that he has clearly mentioned within the closed interval of a comma b it has to be continuous, and within the open interval of a comma b the function f of x has to be differentiable such that in future this condition should not appear. Did you get each and everything? So this is what the basic concept behind the Rolle's mean value theorem. Is that part clear? This was the concept behind the Rolle's mean value theorem. So let me take one problem. So I have taken a problem like f of x is equals to of. You may take sine of x. Just for the sake of simplicity, I have taken sine of x, and the study has to be made over the interval of maybe 0 till pi. I need to calculate point C which satisfies the Rolle's mean value theorem. May I know how will you deal with? First, you will see all of the conditions are getting met or not. As far as the sine x is concerned, we have seen the curve as a sine x is a smooth curve throughout the range of x. That means you need not to worry about the continuity as well as differentiability. Why? I have already said as per the required condition, the function has to be continuous within the closed interval of a comma b. Here it becomes 0 comma pi, and it has to be differentiable within the open interval of a comma b. Here it's going to be 0 comma pi. But as far as the sine x is concerned, throughout the range of x, it's a differentiable. By default, it's a continuous. So you need not to worry about the first condition, which was the condition of continuity, and the second condition, which was the condition of differentiability. Now definitely you have to look after the third condition, what it was. At the extreme values, what are the extreme values? At a and at b, the worth of the function has to be very same. It is there, no? It is there. How? The function is nothing but sine of x. The extreme values, two different method. Either you can use the graphical method, either you can use a mathematical method. So what we are going to do? So at least one point c will fall within the open interval of a comma b such that the derivative of that function at that point c would become 0. So straight away I am going to differentiate sine of x, and I would compare with 0. So may I know what would be the result out of this? It's going to be cos of x is equals to 0. May I know what are the possible values you would be getting out of this? You would be getting the pi is the possible value, 3 pi by 2 is possible value, and it would keep move on. Even it will go towards the left hand side also. Is the part clear? Just a minute. It's a pi by 2. Is the part clear? And even it will go towards the minus pi by 2. So I need to pick the data which comes in between the open interval of 0 comma pi. So definitely the answer is going to be pi by 2. So as far as the answer for this problem was concerned, it's simply going to be pi by 2. So may I know now everything is okay or what? Is still lagging? No, probably each and everything is fine now. Just a minute. Fine, no? Okay. Everything is fine, then we'll move forward. Or you can even solve this problem, graphically. How would you solve this problem? So just take a xy plane, let's take it's my x-axis, let's take it's my y-axis, draw the sine of x, the sine of x would be sort of this. May I know what are the border lines or what are the borders? The borders are at x is equals to of 0. This is nothing but the x is equals to of 0 axis, and the another one is nothing but the x is equals to of pi axis. May I know precisely where the slope of this function is going to be 0 within the open interval of x is equals to 0 to pi? Definitely the point is nothing but x is equals to of pi by 2. Even graphically also you can solve this problem very well. So I would recommend whenever you have the problem related to the RMVT, what you do? First you try to check it out, the worth of the function at the verge, extreme left side and extreme right side, whether they are same or not. If they are same and the functions are found to be continuous and differentiable within the open and close interval of f of x, at least one c would lie in such a way that the slope of the function would become 0 at that point. Is the part clear? So probably hope so I could communicate which I wanted to communicate to you guys. Anyways, I am going to take one problem from the booklet, the things would be even clear. Sir, what we call the point of inflection, the one question have been asked from the JS Agrawal. Anyways, JS Garg, from tomorrow onwards the concept of maxima and minima is going to start, and really you are going to enjoy that part, and there we are going to talk about the point of inflection or saddle point and what does actually they mean for. So you need not to worry about that. We are going to discuss about the point of inflection as well as saddle point in tomorrow's class, because they are part of the concept of maxima and minima. So now what we'll do now, we'll go to the next kind of mean value theorem, but before this let me copy this part. Just a minute. Yes, let me paste it over here. So now we are going to deal with Lagrange's mean value theorem. Put it the heading as LMVT. 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 Put it the heading as LMVT. Lagrange's mean value theorem. And as we had the required condition in case of RMVT, the same condition is also possessed with the LMVT. The starting two conditions remains very same. If you have taken a function f of x, and if the study has to be made taking the reference of x is equals to a and b, then the function must be continuous within the closed interval of a comma b, and similarly function has to be differentiable within the open interval of a comma b. A comma b. A comma b. Is the part clear? But here straight away we jump to the conclusion. Straight away we jump into the conclusion. Here f of a is not very necessary to be f of b. Here conclusion we are going to write. Conclusion. The conclusion states f of b. It's a very, very important conclusion, and graphically once I'll really explain what does this expression stand for, really you guys are going to enjoy the engineering mathematics. So here f of b minus of f of a divided by of b minus a is equals to of f dot dash c. There at least one c would be there, at least, like we had last time, at least one c would be there within the open interval of a comma b, where f dash c would be equals to of f of b minus of f of a divided by of b minus a, divided by of b minus a. Is the part clear? So the conclusion what they have drawn, the f of b minus of f of a divided by f b minus a would be very same as equals to of f dash c, at least at one point c where the c falls in between a comma b. At least one point where the c falls in between a comma b. A comma b. Now I know many of them would be said by seeing this expression. Sir, from where this expression have come? That is why I am saying that's the difference whether you study the mathematics, whether you learn the mathematics. Now I am going to give the insight behind this expression, and definitely you guys are going to enjoy this. So let me do one thing. Let me shift towards the upside. So the face which was crying, let it take upside. Yes. Now just focus on this point. Graphically we'll try to understand. See, I have again taken a xy plane. Let's take this is what my x-axis, and let's take this is what my y-axis. Now what I have done, I have taken a continuous and differentiable function. Let's take, I have taken a continuous and differentiable function. Agreed? We have got x is equals to a as well as x is equals to b. We have got x is equals to of, let's take here, we have got x is equals to of a, and somewhere we have got x is equals to b. X is equals to of a, and here we have got x is equals to of b. May I know what would be the worth of the ordinate at this point? It's my function f of x, and hence the ordinate value at this point, first we'll take its abscissa is a, and its ordinate would be the worth of f of x at x is equals to of a, and that would become f of a. And similarly at x is equals to b, it would become b f of b. Is it part clear? F of B. Now may I know what is it? F of B minus of F of A divided by of B minus A. B minus A. It's the very same as, let's take this as x2 minus of y2, and let's take A comma of F of A as x1 comma of y1. So may I know what this left hand side stands for? Is nothing but the slope of a straight line which has been made by joining these 2 points. The first point is x2, y2, x1, y1. In the first class I have already communicated the slope of a line would be equals to of y2 minus of y1 divided by of x2 minus of x1, or I can say fb minus of fa divided by of b minus of a. What does that mean of it? That means I am going to approximate this as a straight line, this as a straight line, and as the straight line has the unique slope throughout its range, so anywhere if you want, the slope would be equals to how much? F of b minus of f of a divided by of b minus of a. Anywhere you can calculate. But as per the conclusions of Lagrange's mean value theorem, it is being stated in between the range of a comma b there would be another point c where the slope would be very same. The slope would be very same as the slope is f of b minus of f of a divided by f b minus a. You can see where the slope would be very same. So you just try to draw the tangent over the different points over the f of x. So somewhere here you would be finding a situation where the tangent over the f of x is very parallel to the straight line which is crossing through to this point. So easily I can say the slope at the instantaneous point x is equals to of c, x is equals to c, is very same as the slope f of b minus of f of a divided by f b minus a. Is that part clear? Till this, is that part clear? Now try to understand. Now the most interesting thing is supposed to happen now. See. Try to understand. May I know what it is? It's nothing but average slope. And this is nothing but the instantaneous slope. For the better understanding, what I did, I have taken x-axis which I have dedicated to the time, and similarly y-axis I have dedicated to distance. Now take an example, like your father have given bike to you, and you have started driving the bike, and I have started analyzing your bike driving pattern from t is equals to of a onwards. What is happening over there? You are just driving your bike here and there. You are keep increasing your distance. And the last point where I have measured the how much distance you could travel, that I have noticed at t is equals to b. So may I know what would be this difference? This would be total distance traveled by you. Yes or no? This would be total distance traveled by you. May I know what would be the worth of it? That would be f of b minus of f of a. So I can say f of b minus of f of a is nothing but the total distance traveled by you. And may I know what is this b minus a? The b minus a is nothing but the total time consumed by you. So overall, f of b minus of f of a divided by f b minus a is nothing but your average speed. Sometime you must be moving in the higher speed, sometime you must be moving in the lower speed. That is what is happening. No, somewhere you are seeing the acceleration is high, somewhere it's low. That's fine, everything is fine, but what's the result out of this? The total distance traveled is nothing but the f of b minus of f of a. In how much time? It is nothing but b minus a. So may I know what it is? It's the average speed, or in general or in mathematical formula you can just say it's nothing but a average slope. Is that part clear? It's nothing but a average slope. So what Lagrange's bhai is trying to say? Your average slope of the function would be very same as a which slope it is? Instantaneous slope of the function at the point C, where the C will lie in between A comma B, or I can say the average slope or average speed would at least meet a point C in between A comma B, where the average slope would be very same as an instantaneous slope. You can see it's nothing but the instantaneous slope is nothing but very same as the average slope, is nothing but the average slope. Is that part clear? What does it mean of it? Try to understand in this way. If the bike was given to you, or the bike was given to you by your father, and your father have already said, do not go beyond 70 kmph. Do not drive the bike beyond 70 kmph. 70 kmph. What happened? Within 2-hour span of time, you roamed around here and there, you came back to the house, your father noticed the total distance which you could travel was 160 kilometer. 160 kilometer. May I know what's the 160 kilometer? 160 kilometer is nothing but the FB minus of F of A, and similarly, may I know what's the 2 hour? 2 hour is nothing but B minus A. Once you'll divide them together, may I know what is the average speed or average slope of your function? It's nothing but 80 kilometer per hour. That's fine. We got to know about the average slope or the average speed. But if your father knows little a bit regarding the mathematics, he will conclude one thing. As per the Lagrange's mean value theorem, at least a movement would come in such a way that the instantaneous slope, here it's the instantaneous speed, would be very same as the instantaneous, would be very same as, just a minute, instantaneous, just a minute, I am just waiting for the time being, what I am saying. So from here at least your father would figure it out, it was your average speed, and in between A comma B, anywhere at least one point C would be there, where your average speed would meet to your instantaneous speed. That means somewhere your milometer have gone to 80 km per hour. Somewhere your milometer have gone to 80 km per hour. 80 km per hour. Let me see which inputs. So any doubts if you guys are having, you can ask till this point. If any sort of doubt you guys are having, you can ask till this point. That means your father can caught you red-handedly, like in between the span of your drive, somewhere your instantaneous speed has to meet your average speed. Your father will not know about the instantaneous speed. You may bluff him. No father, I did not go beyond 70 km per hour. But if your father knows about the Lagrange's mean value theorem, he will calculate the average speed or average slope, which he got to know about 80 km per hour. So as per the Lagrange's, somewhere your instantaneous speed or instantaneous slope went to 80 km per hour. That means you were driving somewhere with the speed of 80 km per hour, and he can caught you. Now the last point you can write, RMVT is the limiting version of LMVT. Why so? in case of RMVT, we also used to have another condition where the f of A has to be very same as f of B. If f of A and f of B is very same, what will happen? This numerator will become 0 and hence f dash C would become 0 and remaining concepts remains very same, and I can conclude a straight outcome that f dash C would be 0 at least once within the range of A comma B, and which is nothing but the RMVT. So you can say the RMVT is just a limiting case of LMVT. Is that part clear till this point? So let me go to the next point, and thereafter we are going to take the problems related to the LMVT, RMVT as well as CMVT. Is that part clear? So now go ahead with the CMVT. So now also the same condition has to get followed, but here we are not going to deal with a single function, we are going to deal with the two functions. Let's take the two functions are f of x as well as g of x. Now both had to satisfy this condition or this requirement, where the continuity has to be ensured within the closed interval of A comma B, and at the same time the differentiability has to be ensured within the open interval of A comma B, obviously for both f of x and g of x. So most of the time I have seen the student used to have ambiguity. Sir, how will we know that we are going to deal with RMVT, LMVT or CMVT? See, in case of RMVT and LMVT, only one functions would be provided to you. But in case of CMVT, the two functions would be provided to you. So definitely you made a bifurcation that yes, this problem is from CMVT and this problem is from LMVT or RMVT. Now the second question comes, how will you know whether it is a problem of LMVT or RMVT? See here, you need not to worry about it. RMVT is the limiting case of LMVT. So just assume if you had to deal with a single function and if you had to play with the mean value theorem, by default assume that problem is a problem of Lagrange's mean value theorem. That's a different story together. If f of B is equals to of f of A, by default the problem will fall under the Rolle's mean value theorem. So I would say, how will you distinct which type of problem you are going to face with? If only one problem is being given, no. Only one function is being given and you have to play with the mean value theorem, by default assume the problem has to get solved using LMVT. Why? If f of A is very same as f of B, still you would be able to approach that problem with the concept of LMVT itself. Similarly, if you have got the two functions, f of x and g of x, there is no other hope, you have to go ahead with CMVT. Is it part clear? So probably, hope so, I could communicate what I wanted to communicate. So now let me do one thing. Let me delete this part. So the mathematically, what conclusion we can derive from CMVT? See. If the function would have been f of x as per the LMVT, there could have been situation f of b minus of f of a divided by of b minus a would have been equals to of f dash c, where the c is the point in between a comma b. Similarly, now if you deal with g, again you have to take the range of b to a, b minus a, again the same situation will get arrived. So do one thing, let's divide equation 1 and 2. If you divide equation 1 and 2, what will happen? B minus a will get out, and the result which would come in our hand, and that is going to be the result of Cauchy's mean value theorem, and here it's gonna be this. So if you talk about the formula which is used behind the Cauchy's mean value theorem. So that's going to be f of b minus of f of a divided by of g of b minus of g of a is equals to of f dash c divided by of g dash c. G dash c. Is the part clear? So please make derivative chapter of this. PD and GD courses are in Hindi. Okay, okay, we'll go ahead. We'll go ahead. Is that part clear till this point? So let me go ahead and let me take few number of problems. Let me go ahead and let me take few number of problems. Just a minute. So let me take few number of problems. Yes, the first question is coming from here itself. The first question is coming from here itself. Where it has gone, yeah. So you guys had to give the answer for this particular question. You guys had to give the answer for this particular question. Tell me, what would be the answer for this particular question? The mean value c belongs to the closed interval of 1 comma e. F of x is equals to of log of x is. It's a problem of numerical answer type. So you had to feed the answer in a form of numeric. You had to feed the answer in a form of numeric. So can you tell me what's going to be the exact answer for this particular question? That's the first question goes to you guys. I'm just giving the span of 30 seconds. So whatever the answers you guys are giving, I'm just watching over the comment box. Tell me what would be the answer for this particular question. What would be the answer for this particular question? Answer have come as 1. What about the rest of the people? Tell me what's going to be the best most answer for this particular question. So definitely, if we had to play with the mean value theorem, and that to only one function has been provided with your question, by default the problem has to be dealt with Lagrange's mean value theorem. So just assume this is the problem of Lagrange's mean value theorem, LMVT. There is no doubt in it. I am not going into the great detail of log. That means it's a base of x. It's a continuous as well as differentiable in the entire region of x is equals to of 0 plus. In the entire region of x greater than 0, the log of ex is continuous as well as differentiable. Continuous as well as differentiable. Even you can see the log of x curve over the 2D plane. And definitely 1 as well as e comes into the range of x greater than 0 by default. Within the range of 1 comma e, the function log of x would be continuous as well as differentiable. I need not to worry about that. I need not to worry about that. That means the starting two conditions definitely are going to be met. I need not to worry about them. So straight away I'll jump into the mathematical part of it. What is that? F of b. First the b is how much? Let me write there itself. What is the b over there? B is nothing but e, and similarly a is nothing but 1. So f of b would be equals to of log base of e minus of log base of e of 1 divided by of b minus 1. B minus 1. What is the b? B is nothing but e minus of 1. E minus of 1 is equals to of. You will take a differentiation of log of x. You will take a differentiation of log of x, and which would be equals to of 1 upon x, where the x has to be fed as c. X has to be fed as c. Is that part clear? So log of e, when the base and radix matches, the value will become 1. Irrespective of its base, if log is getting applied on 1, the result becomes 0. divided by of e minus 1. E minus 1 is equals to of 1 upon x, or c you can say, 1 upon c. C. So easily you will get to know the value of c is equals to of e minus 1. E minus 1. E minus 1. So in decimal form you can get this answer. You can get this answer. The answer is simply gonna be, let me check it out. The answer is simply gonna be 1.71828. 1.71828. Is that part clear to all of us? Is that part clear to all of us? Is that part clear? So let me take the next question. Let me go up. Yes, you can take this as a next question. So now you guys had to solve this problem. The question number 7. The question number 7 goes to you guys. The question number 7 goes to you guys. Tell me what would be the perfect answer for this particular question. What would be the perfect answer for this particular question? A function f of x is equals to of 1 minus of x square plus of x cube is defined in the closed interval of minus 1 comma 1. The value of x in the open interval minus 1 comma 1 for which the mean value theorem is satisfied. For which the mean value theorem is satisfied. Satisfied. Yeah. In very initial classes, I have already communicated one thing. As far as the f of x is equals to of 1 minus x square plus x cube as a function is concerned, it's a form of polynomial, and polynomial used to be continuous and differentiable throughout the entire region of x. So you need not to worry about the first and second. Although they have given or not given, you should be able to judge that. But the study has to be made over minus 1 and 1. Study has to be made over the minus 1 and 1. What I will do, the minus 1 I will take as a, and similarly 1 I will take as b. I will take as b. And only one function has been given. Assume this is nothing but the Lagrange's mean value theorem. Lagrange's mean value theorem. What it is? F of b. F of b. That means f of 1 minus of f of a. F of minus 1 divided by of b minus of a. B minus of a. May I know what's the b over there? The b is 1 minus of minus 1. Minus 1. At denominator it would become 2. It would become 2. May I know what's going to be the f of 1? You need to feed 1 over here. You will feed 1 over there here, so it will become 1 minus of 1 plus of 1. 1 and 1 goes off. The result would simply be 1 with a minus sign of. Once you will feed minus 1, what would be the outcome? It would become 1. Here it will remain minus of 1, and here it would become minus of 1. Minus of 1. Yes, no? If you are keeping x is equals to of minus of 1, x square make it positive. Positive with the minus sign will be make it negative, and similarly x cube where the x is negative, so the x cube will also be negative, and hence the structure is gonna be 1 minus 1 minus 1. Here this and this goes off. So here the result is simply gonna be minus 1. Minus 1. So may I know what's the result we get it? We get it 2 divided by f2 which is equals to 1. 2 divided by f2 which is equals to 1. Is that part clear? 2 divided by f2 which is equals to of 1, and as per the conclusion there would be a c within the open interval of minus 1 comma 1. Open interval means that should not include minus 1, that should not include plus 1, such that the instantaneous slope would be equals to of average slope. So first you have to get the differentiation of the function. Once you will differentiate it, you will get 1 minus of 2x plus of 3x square. 3x square is equals to 1. So I just wanted to get the result for this. So this and this is going off. So only a polynomial equation is being left out. 3x square is equals to of 2x. So you can do one thing. Minus of 2x is equals to of 0. The x can be brought out as a common. the factor which would be left out is 3x minus of 2 is equals to 0. So how many number of results we have got it? First is x is equals to 0 and the next is gonna be 3 divided by f2. 3 divided by f2, just a minute. Is there any mistake? Just a minute. Anywhere mistake I have made? Yeah, here. Here I have did a mistake over there. Yeah. Yes, at right side. Yeah, so what we'll be doing over here? Just a minute. Get the value of x out of this. So you need to get the value of x out of this and you will be getting the answer out of this. Get the value of x. How much x we get? Or either just by plugging the inputs you can satisfy which data is getting satisfied. Tell me what's going to be the answer. Now. Tell me, so let me do one thing, let me use the calculator. It's a 5, it's gonna be 3, then 2. The answers are gonna be 1 by 3 and minus 1. The answers are coming 1 by 3, just a minute. It's a 1 by 3 plus or minus 1 by 3 and minus 1. And as I have said, the C should fall within the open interval of minus 1 comma 1 and hence this minus 1 has to get dropped. Is that part clear? So the best most answer is going to be option C. Or I can say at x is equals to of 1 by 3. The instantaneous slope of 1 minus x square plus x cube taking the reference of minus 1 comma 1 would match to its instantaneous speed or instantaneous slope. Is that part clear? So probably this is not the correct time to go ahead with the fresh topic where we are going to discuss regarding the polynomial as well as expansion in terms of Taylors as well as Maclaurin's. So hope so I could communicate almost all of the points which were very necessary to at least understand the concept of mean value theorem, and probably you guys would able to solve the problem easily. Now we can have a discussion over there. Any sort of doubt if you guys are having, if any sort of the doubts you guys are having, you can just ask from me and probably we would end the today's session here onwards. Tell me if any sort of doubts you guys are having, not only technical doubt, even the non-technical doubts also if you are having, you can ask over here. Jayesh Garg, all clear sir, thank you dear, great. Remaining people? Just I would request from each and everyone, please comment with your city name along with the state. So I would be able to know from which are the part of our country the people here are getting connected with us. So I would just ask to comment each and everyone who have been connected with me using this live session, put their city name as well as their state. And then we'll terminate. Nellore AP, Lakshmi Priya, good dear. Jayesh Garg, sir, you are teaching nice, sir. I am attending. Thank you, dear. Kannauj, Uttar Pradesh, Nagpur, Maharashtra, Aligarh, UP, Vijayawada, AP. Mumbai, Maharashtra. LFP, Kerala. I have been there many of the times. Vellore, Tamil. Tamil Nadu. I have gone 2 or 3 number of times in Vellore because my boss was from the Vellore. Thanks. So okay dear, today I am not going to start the series expansion and all. I would recommend to each and everyone at least try to share this session to maximum people you can share, such that it will give an immense amount of energy to us and we would be delivering in the great enthusiasm. Great enthusiasm. Anyways, we'll meet probably tomorrow at the same time with the same enthusiasm, with the same passion. So take care, we'll meet tomorrow. Thank you very much.